Hello, good evening everybody. Welcome back to a new video. In today's video we have got an important topic related to chemistry, but this is very important in all the subjects, from biology to physics, and this is also related to our everyday life. So today's topic is evaporation. Without wasting time, let's get into it. First of all, evaporation is a physical property of a liquid. You need to understand this. This is not a chemical property. This is a physical property. There is no involvement of bonding into it. We can say like direct involvement of bonding, chemical bonding into it. Hence, this is a physical based system or physical based phenomena. Hence, we are naming it as a physical property of liquid. And yes, uh, there are other physical properties of liquid as well. For suppose condensation. uh, the same way we have got evaporation, and you can see that there are beautiful diagrams over here. One is showing the tea kettle, and you may see that there is a smoke up into the sky from this kettle. So if you're gonna see into this kettle, you're gonna see into this kettle, so there would be tea inside it, right? There would be tea over in this surface, and uh, you know some particles are escaping from the surface into the atmosphere. This is evaporation. This liquid tea is being evaporated in the form of gas. Gases vapors are being taken out. This is a slow process, even though you may need to heat for a long time. You need to heat for a long time water or tea to get it fully evaporated. Okay, so here you have the same example. Like in this you have got some sort of liquid, and it is evaporated in the form of vapors, and this is from this. So of course, this is a cooling effect. And why this cooling effect? Because the particles on the surface are that much energized that they are being released into the atmosphere. So how do they get energized? Because they are absorbing the heat energy that is being supplied from the stove or gas stove. And that is how they are absorbing energy, and they are doing a cooling process. Because when these particles get released, so there is a heat released. Even though you may consider that is endo exothermic something happened, but to relate it from the backward process. Like here we have given the heat that has made this thing possible. So this is overall an endothermic process, while the result is of course exothermic. While we can say that this is overall an endothermic process because heat is required. Now we have got some beautiful diagrams for you to understand more of it. Evaporation. Yes, fast particles, high kinetic energy near the surface may escape slow molecules left behind. What does this mean? The fast molecules do refer to the molecules which are having higher kinetic energy, and that is because they have absorbed more heat, and they just get released while the slow one are behind. So of course, you can see that the high fast molecules are high energy molecule releasing. So this is uh, you know uh, in a way exothermic. But what has made this happen? This is endothermic. Now average kinetic energy of the releasing molecules decreases. uh, yes, this is a cooling effect, because the kinetic energy, the heat over here average, the one at the topmost get released. Now you can see that here they are slow, and this averagely gets slow when the topmost molecules get released. And uh, temperature of the liquid gets down. It is cooling effect, as I've shown you guys. Now over here we have got another slide which shows surface molecules absorb heat. Yes, that is the thing I have told you. Surface molecules absorb heat, increase kinetic energy of the molecule, overcome force of attraction. This is all the steps. Overcome force of attraction, escapes into the gas or water vapor form, decrease the kinetic energy in remaining molecules, and cause cooling. This is the summary of the topic. Like Here you're gonna see the gas molecules are high gas energy particles or molecules, while liquids over here is the one which is left behind. This is high kinetic energy molecule escape, surface molecules less kinetic energy, and downward the same case. Well, let's talk more on it. So the spontaneous change of liquid into the vapors at any temperature is called evaporation. Like every liquid has got its own point of evaporation, and uh, you know, okay. So there are some factors affecting the evaporation as well, like surface tension. Oh, sorry, the surface area. Now, what does this mean? Like, uh, you know, here is a beautiful example. Let me make you understand from this diagram to you guys. This is, there are some factors affecting the rate of evaporation. Now here you're gonna see that we have got a small hole, and what is the evaporation rate? This is slow as compared to this one. It is having large area, surface area, and there is large evaporation. Simply this is a factor. Like the surface area also uh, you know uh, explains the evaporation or affects evaporation. Like the small hole, small surface area, we have got less evaporation. In the large you have got more. And intermolecular forces also do play a role. Like the one which are weaker, of course they will take time, and the one which are the weaker will get more easily evaporated, while the one which are strong will take time. And uh, other factors are as well, like humidity, wind speed. If wind speed is more, the evaporation would be easy, and all that factors affects. So I do hope that you've got the topic. If you did, do like the video. Meet you guys in the next video. Till that, goodbye.